this episode of IndaPoint Technologies podcast. Join host Emily Carter, an enterprise AI architect, and guest Michael Grant, an AI strategist with expertise in enterprise solutions, as they explore why full fine-tuning remains vital for deep domain specialization. Discover insights on training complexities and benefits in AI applications.
Welcome to today's episode, where we're diving into why full fine-tuning still matters for deep domain specialization. Michael, let's start with the basics. Why is full fine-tuning so crucial for specialized fields like legal or medical AI?
Great question, Emily. Full fine-tuning is essential because it allows us to reshape the internal representations of the model. This means we can tailor it to understand the nuances of specific domains, like the complex language used in legal documents or medical terminology.
Absolutely, and when we talk about precision, we're also referring to the model's ability to improve reasoning and reduce hallucinations. How does full fine-tuning address these issues?
Well, by fully fine-tuning a model, we're essentially retraining it on domain-specific data. This process helps the model develop a more accurate chain of thought, which is critical in reducing errors like hallucinations. The model becomes better at reasoning because it learns to focus on relevant information.
And speaking of focus, let's touch on the technical side for a moment. What about the GPU requirements and training complexity? Are these significantly higher when performing full fine-tuning?
That's a critical consideration, Emily. Yes, full fine-tuning can be resource-intensive. The GPU requirements are generally higher because we're retraining the entire model rather than just adding a few layers or tweaks. This complexity is necessary to ensure the model fully adapts to the new domain.
Absolutely, and in terms of long-term benefits, what do you see as the main advantages of committing to full fine-tuning for organizations?
The main advantage, Emily, is achieving a higher level of accuracy and reliability in domain-specific tasks. With full fine-tuning, organizations can expect better performance outcomes, such as improved decision-making support in legal cases or more accurate diagnoses in medical applications.
That level of reliability is invaluable, especially in fields where errors can have serious consequences. Can you give us an example of how full fine-tuning has been applied successfully in a specific domain?
Certainly, take the medical field, for instance. Full fine-tuning has enabled models to better interpret medical images and patient records, leading to more accurate diagnoses. This is because the model has been trained to understand the context and specificities of medical data.
It truly is, and it sounds like the key is in the deep understanding of the data. How does fine-tuning differ from other approaches like transfer learning when it comes to this deep domain specialization?
That's an important distinction, Emily. Transfer learning typically involves using a pre-trained model as a starting point and then adapting a small part of it to a new task. Full fine-tuning, on the other hand, involves retraining the entire model, allowing it to adapt more thoroughly to the new domain. This leads to a deeper integration of domain-specific knowledge.
Exactly, and I imagine that this comprehensive approach is what makes full fine-tuning so effective for reducing hallucination and enhancing reasoning. What challenges do organizations face when implementing full fine-tuning?
One of the biggest challenges is the need for high-quality, domain-specific data. Without it, the fine-tuning process can't fully capture the nuances of the domain. Organizations also need to consider the computational resources required for retraining large models, which can be a barrier for some.
That makes sense. It's a significant commitment, but the payoff seems substantial. What advice would you give to organizations considering full fine-tuning for their models?
I'd recommend starting with a clear understanding of the specific goals you want to achieve. Ensure you have access to relevant data and are prepared for the computational demands. Collaboration with domain experts is also crucial to guide the fine-tuning process.
That's great advice. And as we look to the future, do you see any emerging trends or technologies that might impact the process of full fine-tuning?
Absolutely, Emily. Advances in hardware like more efficient GPUs and TPUs are making full fine-tuning more accessible. Additionally, developments in automated machine learning, AutoML, could simplify some of the complexities involved in the fine-tuning process.
It's exciting to think about how these advancements could broaden the accessibility of full fine-tuning. How do you see these changes affecting the landscape of AI in specialized domains?
These changes could democratize access to powerful AI tools, allowing even smaller organizations to leverage full fine-tuning for domain-specific applications. This could lead to more innovation and better solutions tailored to niche markets.
It certainly is. Michael, before we wrap up this segment, is there anything else you'd like to add about the importance of full fine-tuning?
I'd emphasize that while full fine-tuning does require a considerable investment, The benefits in terms of accuracy, reliability, and domain-specific performance make it a worthwhile endeavor. It's a powerful tool for organizations looking to push the boundaries of what's possible in their fields.
Thanks for that insightful summary, Michael. As we move forward, I think it would be interesting to explore how full fine-tuning interacts with other AI strategies. What are your thoughts on that?
That's a great direction, Emily. Full fine-tuning can be seen as part of a broader strategy where different AI techniques complement each other. For instance, combining full fine-tuning with techniques like reinforcement
That's a
learning can lead to
fascinating
even more robust
combination.
models.
It really is. And what about the integration with real-time data processing? How does full fine-tuning support that?
Full fine-tuning can enhance a model's ability to process and learn from real-time data by ensuring that it is well calibrated for the specific domain it operates in. This can improve its responsiveness and adaptability in dynamic environments.
So it's about creating a model that's not just accurate but also agile. That's quite powerful. Any final thoughts on how organizations can maximize the benefits of full fine-tuning?
I'd suggest maintaining a continuous learning loop. Even after initial fine-tuning, regularly updating the model with new data and insights from the field can keep it relevant and effective.
Continuous improvement.
It's about evolving
indeed.
with the domain.
Michael, this has been such an enlightening discussion. I look forward to exploring more about how full fine-tuning can integrate with other technologies in our next segment.
Same here, Emily. There's so much potential in combining these techniques to tackle complex problems. I'm excited to delve deeper into those possibilities.
Michael, continuing our discussion, I'm curious about the GPU requirements for full fine-tuning. Are they significantly higher compared to other methods like transfer learning?
Great question, Emily. Full fine-tuning does indeed require more computational resources. You're essentially retraining the entire model, which means you need a powerful GPU or even multiple GPUs for larger models. But the investment can be worth it for deep domain specialization.
So from a cost-benefit perspective, how do organizations justify this investment?
Well, the benefits are substantial. Full fine-tuning reshapes the model's internal representations, making it adept at handling domain-specific tasks. This improves reasoning, reduces hallucination, where the model might generate
That's
incorrect
crucial,
information,
especially in
and
fields
enhances
like law
chain
and
of thought
medicine.
consistency.
Absolutely, in those fields, the stakes are incredibly high. But what about training complexity? Does full fine-tuning make the process more complex?
It does add complexity, no doubt. The training process involves fine-grained adjustments to the model weights, requiring expert knowledge to avoid overfitting or underfitting. However, this complexity is a trade-off for the precision
makes
and
perfect
specialization
sense.
achieved.
Given these challenges, do you think there's a future where full fine-tuning is more accessible to smaller organizations?
Definitely, Emily. As hardware becomes more affordable and open-source tools evolve, I believe we'll see democratization in AI development. Plus, cloud-based solutions are making it easier for smaller entities to leverage powerful computing resources.
That's encouraging to hear. Now, looking ahead, how do you see full fine-tuning integrating with emerging AI technologies?
Integration is key. For example, combining full fine-tuning with reinforcement learning could lead to models that not only specialize, but also adapt dynamically to new data and environments. The synergy between
Such
these
an
techniques
exciting
can drive
prospect.
breakthroughs.
It really is. Michael, before we wrap up, any final thoughts on why full fine-tuning shouldn't be overlooked in domain-specific AI?
Sure, Emily, full fine-tuning offers a level of depth and precision that other methods simply can't match. For industries where accuracy and specialized knowledge are paramount, it's an invaluable tool.
Thank you, Michael. It's been enlightening discussing these nuances with you today. I'm sure our listeners gained a lot of insight.
Thank you, Emily. It's been a pleasure sharing my thoughts. I hope our discussion helps demystify the importance and potential of full fine-tuning.
For those interested in exploring more about tailored AI solutions, you can visit IndaPoint Technologies at https://www.indapoint.com.
Absolutely, Emily. Leveraging expertise like theirs can make all the difference in implementing effective AI strategies.
Michael, I find it compelling how full fine-tuning can really hone in on domain-specific needs like legal or medical fields. Can you shed some light on the kind of GPU requirements we're talking about here?
Absolutely, Emily. Full fine-tuning is intensive. It requires robust GPU setups. We're looking at high-end GPUs with significant memory capabilities, especially for large models. This ensures the model can handle detailed
I can
datasets
imagine the
and
complexity
complex
must be
computations
immense.
efficiently.
And when it comes to the training complexity itself, how does full fine-tuning compare to, say, other tuning techniques like transfer learning?
That's a great question. Full fine-tuning is significantly more complex. While transfer learning involves adapting pre-trained models with small adjustments, full fine-tuning reconfigures the entire model. This allows for a
So
deeper
it's like a
integration of
complete
domain-specific
transformation.
knowledge.
Exactly, and what about the benefits, especially in terms of reducing hallucinations and improving reasoning?
The benefits are substantial. Full fine-tuning aligns the model's reasoning processes with domain-specific logic, which minimizes hallucinations. This is critical in fields like medicine, where accuracy is paramount.
That's fascinating, Michael. And how does this improve the model's chain of thought consistency?
Well, by reshaping the internal representations, the model develops a more coherent understanding of domain-specific processes. This leads to more consistent and logical outputs,
Which is
enhancing the
exactly
model's
what users
overall
need.
reliability.
Absolutely. Do you think we'll see more industries adopting full fine-tuning for their AI solutions?
I believe so, Emily. As AI becomes integral to more industries, the need for domain-specialized models will only grow. Full fine-tuning is one of the best ways to achieve this specialization.
It's exciting to think about the potential. Before we wrap up, any final thoughts on the future of full fine-tuning?
The future is promising. As technology advances, full fine-tuning will become more accessible, allowing even more precise and powerful AI applications across various sectors.
Thank you, Michael, for sharing your insights today. For those interested in implementing tailored AI solutions, IndaPoint Technologies can be a great resource. Visit IndaPoint.com for more information.
Thank you, Emily. It's been a pleasure discussing the critical role of full fine-tuning in AI specialization.